Today's lesson has to do with the classification of matter, and we are going to see what are pure substances and mixtures, and talk about heating and cooling curves and solutions. Said matter is everything that has mass and takes place. And most of matter consists of mixture and pure substances. So matter is classified in homogeneous substances and heterogeneous substances. Heterogeneous substances have visibly distinguishable parts, and they are mechanical mixtures and can be separated by hand. Homogeneous substances, on the other side, they have visibly indistinguishable parts. We cannot see different phases there, different states of matter. And homogeneous substances are divided in pure substances and homogeneous mixtures, which are solution, and pure substances are elements and compounds. You might see another classification of matter when is given sometimes that matter is classified in heterogeneous substances, homogeneous mixtures, and pure substances, but is the same thing. What are pure substances? Pure substances consist in only one substance. An element is a pure substance like oxygen, hydrogen, or a compound, H2O, or calcium oxide. A pure substance boils and melts at definite temperatures, and the values of temperature are precise and predictable, and they are used to identify substances sometimes. And something else to say about the melting and boiling points is that in relation to room temperature, they determine the state of the substance. What does it mean? Water has a melting point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. In room temperature, which is 22 degrees Celsius, water is in the liquid state because above 0 degrees Celsius, but hasn't evaporated yet, so it's not gas yet, so it is liquid. But this is for the, as I said, pure substances have precise values. When we have impurity, the melting point lowers and the boiling point it raises compared to the pure substance. For instance, we have water and H2O. They are not the same thing. H2O is a pure substance, has hydrogen, 2 molecules of hydrogen and 1 oxygen. Water on the other side has different salts in it, so is impure. And in the water, it is going to have maybe slightly higher boiling point and lower melting point than H2O. Those values are for the pure water. Before I go further, I want to talk about this apparatus. This is an apparatus that is used to measure the melting and boiling points of substances. And this one hanging here, it is thermometer, and the other one is a tube where the substance is placed that we're going to measure. And this tube is placed in a test tube, which is put in a beaker with water, like a bain-marie. While we heat the water, the temperature would rise, and the substance is going to melt to a point and boil in another point, and we read these temperatures, and based on them, we build heating and cooling curves. What is a heating curve? Here is in this graph we have plotted the temperature against time, and this graph expresses the changes of the different states of substance. Let's say this is for the water. Now we know, first of all, energy is needed to change a solid into liquid or liquid into gas. We all know that. Let's say this is water, and here in the point A we are like 10 degree under minus 10 degrees Celsius, and the temperature rises like with time. We get to the point when we have 0 degrees Celsius and the ice starts melting. At this point, the temperature is going to plateau. It's not going to increase anymore. It's going to stay the same until melting is complete. And in the BC part of the graph, we are going to have water and ice in the same time. In the C point, all ice is melted. We have just liquid. And after that, the temperature starts increasing again to the point of boiling point. And here, the water starts boiling and we have steam going up, gas going up. But for a while, the temperature is not going to change. But during all this process, the temperature for water, for instance, is going to be 100 degrees Celsius, and liquid is going to be boiling until boiling is complete, until we don't have any more water. And after that, the temperature starts increasing again, gas. Keep in mind, while the water boils, doesn't matter how firstly this boiling is and for how long the water boils, the temperature in the water is not more than 100 degrees Celsius. The steam, the vapor, the gas has the higher temperature. Cooling curves are the reverse process, and energy is given out. So we have gas here which is being cooled. It gets to the point of boiling point when gas starts condenses, and for a while the temperature is going to stay the same until all gas is turned to liquid. So in this part here we have gas and liquid, and after all the gas is turned to liquid, the temperature starts decreasing and liquid is being cooled till the point of freezing, and liquid starts freezes. And in this part here, the temperature stays the same. We are going to have liquid and ice until everything is turned to solid. We have ice in the case of water, and temperature is the same. And at this point when everything is turned to solid, solid is being cooled and temperature decreases. Now, as I said, pure substances have precise boiling and melting points. And if we have impurities, the melting point is going to be lower and the boiling point is going to be higher. That's why maybe you have seen that people take care of the roads during the winter when temperatures are going under zero. They spread salt on the street. They do that because with the impurity, the freezing is going to happen lower than 0 degrees Celsius, and they keep the freezing out of the roads. Now, what are mixtures? Mixtures are made from at least two parts, and they may be solid, liquid, or gas. When states are mixed to become one single state, we have the solution. So here in this picture, we have some solid, that is copper sulfate, mixed with water to give a solution of copper sulfate. The solid dissolved in liquid is called solute, and the liquid that dissolves the solute is called solvent, and what we get is solution. And we don't see anything here, like we don't see these particles of solute, everything is dissolved. But when the states remain separate, we have a suspension, we don't have solution. Suspension, we get this in a precipitation reaction, we can see that later. But look at this, this is a bottle of dressing, the oil is spread, and we have here all the different spices mixed in the oil and vinegar. Solutions are homogeneous mixtures. We cannot see distinguish the parts of solute in the solution. We can have solutions of solids in liquids, solutions of liquids in liquids, solutions of gases in liquids, and solution of mixed gases. And we have alloys also are solutions. Metals, when we make alloys, when metal is melted, and they are mixed when they are in a molten state, and after that they are solidified. But in the molten states, liquid metals, they are solutions. Now you have questions here. Stop the slide and try to answer the questions. If there is something that you don't understand, go back to the slide and look them over. And for next time in homework, you have a quick check questions in page 35, exercises 2, 3, 4, and 5. Blessings.